Actually, there's a lot of people inside the DoD that feel China and other countries have weaponized the periodic table. And that's true across the aerospace and defense industry. Pretty much all of them are working on next generation technology and will need novel materials to solve those in some way, shape, or form. Of all the industries everyone's focusing on, there is a underlying common thread between them. What advanced materials are we going to develop that enable those industries? And I think you're starting to see that become more and more front and center at the geopolitical level today.
Hey, welcome back to the Aerospace Executive Podcast. I'm really happy to have Joseph Kraus with me. Joseph is co-founder of Radical. Radical is based out of New York. It's raised $65 million in funding, and it's new generation, next generation materials development, testing, and it's a cool story. Joseph, thanks for coming on.
Greg, thanks for having me. Happy to be here and happy to talk all things material science and the way they impact some space like aerospace. So appreciate the invite.
So talk about what you're doing at Radical. Tell us what Radical's doing.
Yeah, absolutely. So you take one step back. At Radical, at a high level, is a material science company that is looking to shorten the timeline and cost to discover new materials that impact our most important industries like aerospace. And when you think back to how many industries are really impacted by material science, automotive and aerospace, manufacturing, defense, climate, energy, semiconductors, the most important industries in the world are all a direct result from materials research. But you just have these incredibly long timelines and costs to be able to get there. We build what we call a materials flywheel that takes AI and autonomy at the center and shortens and reduces that cost to really push new materials in the market. So that's what we are focused on.
So who's funding? I mean, obviously, next generation tech startup. I'm going to call you a tech company, a little bit of an older, you're sort of radicalizing an older business, right?
Yes, that's exactly right. 100%. Actually, one of the reasons we got excited about the business was we were looking into AI like everyone is today, right? Everyone's paying attention. And we were frustrated that no one was applying AI, or not a lot of people were applying AI to the physical world. So a lot of stuff in email and marketing and consumer products. What about the real world that builds the things that we use every day? And when you look at material science, companies are 70, 80, 100 years old today with very little to no innovation at the core of what they do. That is the exact opportunity that we identified. And that's what we are most excited about tackling. So that's kind of where this excitement and drive to build Radical AI came from, and why we wanted to go out and really push into such an old industry with such new technology and AI and autonomy.
How many people on your team?
About 30 people today.
All material scientists?
No, split across a wide range of industries. We have 5 different technical disciplines inside the company. We have material science, both on the experimental and computational side, but we have software engineering, machine learning or AI engineering. We have mechanical engineering, and then we have autonomy as well. And that's more of like the robotics function of interconnecting this entire lab. And so a very interdisciplinary team that spans everything from the autonomy to the AI side and materials in between.
So your backers, I saw Raytheon was one of your funders.
That's right. We have a good mix between some corporate VCs, RTX venture arm in there, NVIDIA venture arm, Eni, which is a large energy company based out of Italy, and UDC, which is a big material company, their venture arm, and then some great financial VCs as well, Noah Capital, Infinite Capital, Ali Corp, Tribeca Venture Partners, et cetera. And so we've kind of put a nice cohort together, both the strategic focus, but very much on the financial VC interest as well.
So NVIDIA and Raytheon are 2 very different companies. I mean, obviously they're 2, talk about the materials. I mean, look, we could, jet engines, for instance. You and I were talking, jet engines,
Exactly right.
Nobody's jumping up and down saying, let's build a new generation aircraft because the jet engines are pushing the boundaries.
Some are. It depends. It depends on what speed you want to fly at.
Right.
For those hypersonic speeds, or this becomes a big problem. But yeah, so really interesting. Actually gets at the epitome of why materials are so important. One thing we always talk about as a company, it doesn't matter what industry you care about. We're going to talk about aerospace today, which is one of our first industries and incredibly important. One of the bigger industries that invests in materials research and uses and pushes novel materials into their products. But even in semiconductors, even in energy, all the way through to consumer electronics or apparel. All of those things are these material science driven innovations. That's exactly what is so impactful by Radical AI. And that's how someone like an RTX venture team and ventures of the NVIDIA team can invest in and be excited about the technologies that we're working on. Inside what we're doing today, so we are working in alloys, particularly multi-component alloys that really target some of the problems we feel in extreme conditions, high temperature, high pressure, oxidation-based environments. And you're typically seeing these conditions arise at high speeds. Mach 5, Mach 10, Mach 15, even higher, and then certainly in your space applications as well. And a lot of the materials that we have today usually fail under one of those criteria, right? They may be really strong materials, but not have great thermal expansion, or might be able to withstand a lot of high heat, but under pressure or under oxidation start to lose those mechanical properties. And so what we are optimizing for is how can we make next generation alloys that really enable things like hypersonic or potentially even supersonic flight. And they end up in places like nose cones, like grid fins, like turbines with inside the jet engine and everything in between. And so it's been a huge kind of area for us to look into to start. And a lot of the customer interest has been quite strong given how much those teams focus on material science as well.
Yeah, I mean, it's the stuff your average person never really thinks about.
Absolutely. It's definitely deep in the technical weeds, 100%. And it's an area where, unless to your point, you're deeply in the space, a layperson won't typically come across. But if you think about the turbine, and how important the innovations of materials there, we have been hearing about additive manufacturing in jet turbine blades for a long time. That could drive down, by a huge margin, the cost that goes into manufacture those, given how important they are in the turbine engine. But that's incredibly hard to do. You don't have the same properties when you use AM than if you're using bulk casting or annealing and rolling or whatever other technique you might be using inside the aerospace industry. And so it's this constant battle of doing not only materials discovery, but scale up processing and manufacturing. And that is the missing piece we see inside scaling materials today. It's exactly what Radical wants to help solve. We actually want to do the full vertical integration and manufacture those materials at scale.
So are companies coming to you? Are companies coming to you and saying, "Hey, we're trying to develop this product, and this is the goal. This is what we're trying to figure out"?
That's the place we always start. So whether we're meeting with someone in aerospace, defense, or even space itself, we'll always ask, "Hey, what are your biggest material problems?" And the best part about that, Craig, is you unload and step into. They're like, "Well, how long do you want to be here?" Because I have material problems everywhere. And what we'll really try to understand is, where are there optimization problems? These would be things like, pushing ductility or thermal expansion by a couple orders of percent, 5% maybe. And then where are your enabling, your unlocking technologies, right? This is something like, hey, can you make a much cheaper version of titanium that is much lighter than aluminum? How do you thread the needle right between those two elements there? That would be a holy grail material for the aerospace industry. We don't have something that's great there. We have these super alloys, but trying to push them past their current conditions and their current mechanical performance in those conditions is really important to the space. So we kind of get a download of information from them, and we are typically trying to solve problems in that second bucket, these enabling technologies. We do look at some optimization problems, but Radical's Flywheel is really oriented towards unlocking new technology that previously can't exist from limitations today.
Everybody's talking about rare earths. A lot of rare earth material. It's the buzzword right now. China. It's the big. The fear crisis.
That's right.
You guys, talk about it a little bit.
Yeah, sure. So rare earths, of course, incredibly important. There's a really interesting adage I have around them, which is the reason, or I should say, one of the reasons they're becoming so prevalent and important right now is other countries deeply invest in material science. In the U.S.'s adversaries in China and Russia, if you look at hypersonic technology alone, they both have and have fielded hypersonic technology, given their investments inside material science. China with niobium-based alloys that they've developed over the last 5 years or so. And so now when you see this attention flipping into rare earths, which are, of course, the raw elements or minerals that make up these novel alloys that you can make, it kind of makes complete sense why those become so important when you're trying to develop capabilities that all stem with material science. And if you actually expand a little bit more outside of what would be classified as traditional rare earths and minerals, there's been a big supply chain focus across the entire periodic table. Actually, there's a lot of people inside the DoD that feel China and other countries have weaponized the periodic table. And so even materials like tantalum or vanadium, molybdenum, they're incredibly important to alloys and superalloys. And some of those materials, depending on end user, are no-goes or not, prioritized given their supply chains are mostly not inside the US or friendly countries around, mostly coming from China, candidly. And so we get a lot of questions on, hey, can you get the same performance of this material, but get rid of X element, which we no longer want a supply chain risk for? So you actually see, to your question directly, this question of rare earths and minerals, which has been a focus, expanding outside just the magnets and batteries and those direct fields where they're feeling impact, and moving into even other elements that maybe aren't rare earth per se, but are certainly a question inside the supply chain.
It's a weaponization of rare earth, but hey, look, all's fair in love and war, right? But it makes me think about something different. You guys you have an ability now based on what people have come to you with to sort of anticipate the future.
Well, that's right.
Do you start to spec? Do you start to develop some spec?
In the aerospace industry specifically?
Wherever, you start to develop some spec material that says, hey, look, this is some, and then work with people to manufacture it. I mean, is it?
So yes and no, meaning we don't want to ever push into, manufacturing a turbine, for example, right? That's actually not our business. And actually what we like to tell customers, because it's true, is we're trying to be a vertically integrated manufacturing materials company. And the end customers in aerospace, they don't want to be a materials company, right? They're not a materials company. They're an aerospace company. And so there's this beautiful synergy that forms where we say, oh yeah, we have no interest in competing in the turbine business or whatever, other business. And you probably have no interest in competing in the materials business. Together, we can actually develop technology and be able to put that quickly into industry. And that's where a lot of our push is right now with the potential customers we're talking to around how can we work on this together and solve problems. Aerospace has an additional lens to it that's quite hard. Validation and verification are challenging, right? You have to think about, Boeing or Airbus or GE or whoever else is, or Rolls-Royce, whoever else's research team is. There are people flying with these turbines, right? If you use the commercial aerospace, there's a long validation and testing process that goes into these materials. And we have approaches to take a stepwise based process to get there, but it's not, willy-nilly throw something in and see what happens. These are deep research teams that have decades of experience and who are really looking to push the boundary, but do that in a way that kind of complies with their requirements from a manufacturability and an end component process today. And in the aerospace industry, we get that question a lot. How do we actually solve that? On more exotic technologies, to your point about seeing the future, yeah, we hear some pretty crazy things that they're working on. Now, we don't always get all the details, like they're either, secret or top secret clearance, or even if we just get them, we're under NDA and we can't disclose.
Yeah, no doubt.
But we start to see where they're trying to push future products into and the requirements they're going to need from a material spec. We talk about extreme environments. That's an area that comes up a lot when they're thinking about future products that they're building today. And that's true across the aerospace and defense industry. Pretty much all of them are working on next generation technology and will need novel materials to solve those in some way, shape, or form.
That's pretty cool. How'd you get into this? You're a young guy. How'd you get into this?
Yeah, so, going way back, I'm a material scientist by training. And so, by the way, I love the quote, Steve Jobs quote, you never can connect the dots looking forward. You can only connect them backward. My story now makes so much sense. Every year I was like, I wonder what's coming next. I don't know where we're going. So while I'm back, I'm in graduate school. I was doing a PhD at Rice University in materials. I was working on a lot of novel materials for electronics. And I was super frustrated that all the work I was doing was very fundamental, right? It was going into scientific publications or never leaving academia, right? But there was no end product getting pushed out. And so I actually started reaching out to people, and I bumped into the U.S. Army Research Lab. It's in Adelphi, Maryland, right outside of D.C. And it's the kind of corporate R&D lab that does fundamental research for the U.S. Army, but starts to look at pushing those things up the TRL scale, the technology readiness scale, from 2, 3, 4 into 5, 6, 7. And so it was this fun blend of, yeah, how do we work on really interesting science problems, but look at the end applications that those directly impact, for the taxpayer and for the warfighter. And I had been completely separate to that in the National Guard. I was a U.S. Army soldier in the National Guard. And so there was this deep affinity for me around, wow, I love the science and I love the people I'm trying to help. And so there was this really cool connection between these two things. It was still fundamental. And so I still wasn't fully scratching that itch of, okay, how do I get these things in the market? So I cold emailed a big investor and tech entrepreneur in New York named Kevin Ryan. He runs a firm called AliCorp. And I told him, if you're not investing in material science, you're not investing in the future. And he was like, that's a bold claim. I've been doing this for 35 years. How can you prove that? And I said, look, here's my thesis. Here's what I think you should do. And to his credit, he said, why don't you come up to New York? I'll give you 6 months. If it goes great, amazing, you found your new career. And if it goes poorly, you had a good internship and you can go back to graduate school. And I walked upstairs, told my now wife, honey, we are moving to New York on Monday. And she said, okay. And we packed our stuff and we moved up to New York. And so I began investing in material science, semiconductors, 3D printing, informatics, and kind of had this natural intuition where me and another co-founder of mine, Jorge Colindres, was also at AliCorp, started seeing about where in AI was there going to be the biggest impact. And we were so frustrated by the lack of innovation in the physical world. I mean, Jorge looked at me one day and said, I just don't understand why everyone's building chatbots and marketing tools and no one's trying to move into sciences or curing cancer. And that was where I said, look, materials are the answer to that problem. No matter what industry you want to focus on in the world, we can actually make an impact with novel materials. And we went off and running. We found our third co-founder, Dr. Herd Cedar from California, Berkeley, and started building the company from there.
I love it. I love it. Now, I mean, the OEMs out there have a lot of vested interest. Obviously, IP, material science, moving forward. Are they trying to outsource some of this to you guys? I mean, faster, better, quicker.
Yeah, two ways that we typically see that today. So one is what we call kind of contracted research. And this is where they're trying to get the faster mechanism solved. They cannot do as many experiments as we can, right? We have a full self-driving lab that's fully autonomous. There are no humans in that lab. And so what we're able to do is run hundreds of experiments per week. That's what our target is to get to. And that is really eclipsing the pace of what a human scientist will do in a year in a single week. And so this kind of big magnitude jump on the experimental side. And that allows them to get faster speed in discovery. And so that is one lens that, we get a lot of outreach on and questions around and are talking to potential customers about. We also have another kind of big push in trying to understand how can you actually deploy these things on-prem for teams that really have serious research operations. And there are quite a few large companies in the aerospace sector specifically that have entire research divisions looking at novel material systems for their future products. And there we kind of work a lot around, look, if it's got to be on-prem, if it can't be in our lab, what are you looking for? What do you test for? How do you validate? And there's kind of more of a customization-based approach today where we can actually deliver an on-prem lab solution to them that they can run in high throughput. It's all run by our AI, by our operating system called Antimatter, and kind of really end up trying to push that into their technology stack specifically from a discovery lens. That's where we are today. We are concurrently working in how you go from validation and manufacturing as well, and how do you push through those processes. So that in 5 years, we can be manufacturing those alloys to sell to these aerospace companies.
It's crazy. Where are you finding, look, it's a lot of mental brain power going into V&V, testing, V&V, developing it. You've got your software. Where are you finding? You've got a co-founder from Berkeley.
Yep.
Where are you finding the other? You going to MIT? You going to? Where are you finding your other engineers and your other?
Yeah, it's a great question. So we are honestly insane about our culture at Radical AI. It is the most important thing that we prioritize because our mission is one of the most important in the world. That's what we believe. And if you are not bought into the mission, then it is just too hard and filled with too many failures to actually motivate someone to continue. And so we tell everyone before they come work here, if you are looking for a job, this is not the place for you. You should go work somewhere else. If you are looking to dedicate yourself to a mission that leaves a fundamental imprint on human race, this is the place that you should come. And so we really take a very high bar to that. And then the second is we go look for people who are the best in the world at what they do. And by best in the world, we don't mean the most fame or the most accolade or the most papers. We look for people who are the best at asking why, first principle analysis. We are disrupting a 100-year-old industry. Everything we do is rooted around the question why. Why does it work that way? Why do they care about that performance metric? Why do they make alloys that way? Why is manufactured that way? And why do components look like that? How can we rethink those things from a first principle analysis? And so every person I'm bringing to the company has to have this deep affinity and deep passion for asking the question why. And you start to weed out a very small pool very quickly when you apply those two criteria to the potential targets. And both my co-founders, Jorge and Herd, as well as myself, deeply believe in that. I mean, that is like at the essence of how we believe in building the company. And so it is really carried into the organization quite aggressively.
That's a pretty cool. I was just sitting there thinking, well, the war for talent. Are you the people that you're out there getting, Silicon Valley paying $100 million packages to the best AI guys out there.
AI is crazy.
Best engineers out there
are real in AI.
And materials. Where are the best material scientists coming from?
All over. It depends what they do, right? Yes, you have universities who are very strong inside material science. Your MITs, your Berkeleys, your Rice, your Johns Hopkins, Georgia Tech, Northwestern, et cetera. But you also have a lot of really good research groups inside aerospace and defense, GE Aerospace, Rolls-Royce Research, Boeing's research team, Lockheed Martin, RTX, as well as some of the younger companies that are now getting older that have really good scientists that are looking at fully developed productionized systems like an Anduril or similar. And so there's really an industry, a big push. And then lastly is national labs. You have some very strong national labs, Sandia, Idaho, Oak Ridge, where they have good researchers who are scientific in nature, yes, but who are looking particularly at places like Sandia or Berkeley at the end applications that research is impacting. And they are very good at thinking about the way science is going to really change. And so, again, interdisciplinary, I stress this a lot because it's super important. We pull people from everywhere because we don't just want academics and researchers, and we don't just want 10, 15, 20-year industry personas who have only done that. We want a blend of ideas, a blend of people so that we can ask the first principle from the research question, but we have a lot of information on what the most important thing is to the end customer. That's the exact way we have to go out and build a team. So they are coming from all over.
You talk about building a culture and a culture around why.
Yeah.
What's leadership look like to you guys? From it sounds like you're probably not a very hierarchical organization.
We are not super flat. You're exactly correct. Sadly, than being very flat. So leadership, and I learned a lot of this from the military. I always talk about how blessed and thankful I am I did time in the U.S. Army National Guard because I learned how to be a leader. I think every leader needs to first learn how to follow before they truly know how to lead. And us as leaders, we really believe in leading by example, and to use the cliche, because it's very important. When you are trying to do something that the rest of the world thinks is impossible, it is only you who can actually push through when you fail a lot because you believe in that end vision. And from doing that, the rest of the team will also have the same perspective. And two, bias to action. There's actually a funny notion, and I think your aerospace folks will laugh at this and probably actually take offense to it in some cases. I went on a kind of fit a couple of weeks ago, and I sent an email to the whole company. I banned the word strategy. I said, I don't want to hear strategy ever talked about for the next 6 months until we deliver something. Yeah. I want bias to action. And me, Jorge, and Herd all deeply believe in this. And that's how we lead, not by directing people what to do or telling people that, by executing. And by executing, you learn fast, you solve problems quickly, and then you actually can build a feedback loop from both of those things to build iteration into your process. And if you can continue that cycle, you can really move faster than other companies can move and learn more than other companies can learn. That is at the epitome of how we lead.
Do people have a hard time keeping up? Do people come in and they take a look and they go, "Whoa, these guys move fast"? Not for me. Yeah, is it?
Yep. It's probably one of the more challenging parts of being on the leadership team is not everyone will be able to keep up with the culture or that speed. And our job as leadership in the company is to remove those folks or figure out a way to get them to find a way to how to join. And that's the most important thing that we can do, because if we can't set that bar and then uphold it, why would anyone else on the team do it? And so it is challenging to do, but there are cohorts of people who deeply believe in that. You know, SpaceX has built an incredible culture, and we learn a lot from what the team has done over there. 51% rule being our primary mechanism we take from them, where we are at 51% on a decision, you just execute across that. So you just have to find the right people who subscribe to that philosophy and have the skills to be able to back it up.
Well, yeah, obviously your first venture into entrepreneurship was a cold call to a VC, which is great. I love it.
That's right.
That's how I got my first job out of the Navy.
Exactly right. I mean, I was always told, just reach out and you never know what happens. And that's why I make an effort today. When anyone ever cold emails me and reaches out, I always try to make an answer, because I was in those shoes, and I still am, by the way. I have cold emailed every single CEO of every aerospace company you've had on this podcast or will have on this podcast. And we still operate that way. And I think it gets back to bias to action. You don't know what people are thinking about. You don't know why you might be able to get in front of them. But if you never ask, then you'll certainly never get in front of them.
Never get.
So I think it all comes back to that bias to action mentality. And we even teach the team a lot about when we started the company, we did 800 and something interviews with people to find the initial 20 people. And it was almost all by cold email. There were a few warm recommendations and people reaching out to us, absolutely. But a majority of that was outreaching. And so when any of our department heads or someone that's building a team is like, how do you get in touch with talent? We're like, until you send 1,000 emails, don't even come and ask the question. It's a really big key.
The best tool in business is the iPhone, right? It's the iPhone. What's the biggest challenge you found when you started? You now get your first round of funding. You've got you had an initial round, then you got some more coming in.
Yep.
What was the biggest challenge that you never anticipated? Just getting the business going.
That's a very good question, because it is different today than I think I would have said it before I started the company, which makes sense. The biggest challenge is that you expect, before you start the company, for everyone to understand and see your vision. They know the world's going that way, and they're deciding if you have the right technology to enable it. That's not the case. Actually, no one sees the vision, or I should say maybe not no one, very few people see the vision. And what you've come to realize is that their job is not to see the vision. Actually, that's your job as an entrepreneur. Otherwise, why wouldn't they be the entrepreneur? Mm-hmm. And so I think I had this expectation that investors were going to jump up and down at the excitement of material science. And that's not their job. Investors' job is to return a multiple on the capital that they're granted from their investors, not to see where the future is going. They actually look for the entrepreneurs that see where the future is going. I think that was a humbling, but also exciting realization, because it enabled me to think, wow, I have to believe in this when no one else does. But two, I also believe in this when no one else does. And that is the exact place you want to be in entrepreneurship.
I love it. My good friend Jack Kennedy is the CEO of Platform Science. He's the founder of a company called Platform Science out in California. And I remember sitting in a San Diego restaurant with him, and him telling me all the people that came and said, this will just sell itself. Yeah, he's like, no, nothing sells itself.
It does not. That's exactly right.
And it's a great thing to think that you have to show people your vision. You have to prove it to them every day.
Exactly right. Yeah, and you have to prove why they should spend their hard-earned time, capital, and resources on you as well. Like, I think a lot of entrepreneurs forget that, especially in the early days. There's a lot of companies that big corporations, particularly in the aerospace industry, can work with. And like I mentioned earlier, they're not shipping products every year or 6 months with kind of minimal risk cycles. These are very important, very complex, very expensive, deeply integrated products. And like one customer told me on the first call, why should I put 25 years of research into Radical? Right. And like, trust you to take that over. And there's someone that we talk to very closely and are still working on trying to become a partner with. But It's a fair question. And I think to what you just said is the way you answer that. We show up every day proving what we can do, why we can do it better than anyone else in the world, and why in the next 10 years, that question will be flipped in a positive manner. I mean, you'll have wanted to work with us, especially if you want to be innovative. That's your job as an entrepreneur. And no one owes you anything. You need to earn the respect, the trust, and the time that these folks give you. And I think the better you understand that, the sooner you understand that, the more effectiveness you can have in your conversations where you understand they build a career building these products and you're just starting yours.
That's not just that goes beyond entrepreneurship. That goes beyond every professional out there, right? Every day someone's trying to take your chair.
Yes, it is.
You got to keep it. Right. Is material science, we talked a little bit about the war on rare earths. Is there a war on material sciences right now?
I think there is under the radar. I don't think it's maybe as talked about, although you are seeing stuff come out of Washington, D.C., The Hill, and other big companies like, the MP Materials deal that we recently saw, the big one in material science. But I think the more and more people start to look into specific technologies, for example, semiconductors with the CHIPS Act and kind of this realization, wow, a lot of this innovation is coming from material advancements as well as fab and other infrastructure that needs to be in place. You look at robotics and what's happening there on the automation front and the way that materials help impact that. You look at space and really the future of both space travel, but military space operations. A lot of stuff there. It's a material science problem. Communications, radiation, even the ability to lightweight or block with TPS-based material for extreme environments. It'd be a big fight there, as well as futuristic, future industries like on a surface on Mars. How do you power a habitat on Mars? You're not going to bring a nuclear reactor with you. You're certainly not going to lock up solar panels with you. You're going to put them on the surface. That's a material science problem. We don't have the same elements on Mars that we do on Earth. So I think of all the industries everyone's focusing on, there is a underlying common thread between them, which is what advanced materials we can develop that enable those industries. And I think you're starting to see that become more and more front and center at the geopolitical level today.
You got 30 people now.
Yep.
How fast can you scale? And how fast do you need to scale to keep, I got to think there's a lot of demand out there for what you're doing and, small companies, big companies on, things alike.
So we'll be at 50 people by the end of this year, and then we'll hit a pretty big break on that actually. And we're a deep believer in really not becoming what we kind of in the startup world, quote unquote, a fat organization. You can do a lot more with a lot less people than most people realized. And not that we don't have the capital or the room for these people to come in. It's that we really want to run a lean operation and put our capital to strong, effective use because our mission is a long mission. Like I mentioned, 10 plus years to really go manufacture and sell those materials. And our milestones along the way are incredibly important to accomplish. The best thing we can do is move across those objectives efficiently, both from a capital perspective and a time perspective. And so we'll hire the people that we need to deliver on them, hence the 50 number I just gave you, but we won't bring in extra people that aren't accretive to the exact milestones that we're working towards. That just slows the organization down and increases burn. And for us, we're all about running something that truly reaches the end goal. We want to become the largest materials company in the world. We got 25, 35, 45 years in front of us to scale to thousands of people, and we'll get there over time.
I love it. Hey, Joseph, I could talk about this all day because what you're doing it's incredibly fascinating. But let's do this. Let's call it here and have you come back on.
I'm happy to come on anytime.
And talk about it again.
Absolutely, Craig. Thank you so much for having me. Anytime you want, I'm happy to come on. And as we see materials continue to proliferate, I'm sure we'll have more things to talk about.
Joseph Kraus, Radical, and it's radical.ai. Is that the company?
Radical-ai.com. You can find us there. You can find us on LinkedIn. You can find us on X, or you can reach out to me directly, joseph@radical-ai.com. We'd love to have a conversation.
Great conversation today. Thanks for coming on.
Thanks for your time, Craig.